For centuries, time has been humanity's most relentless mystery, unstoppable, invisible, and absolute. But what if it isn't? What if time, like space, can be bent, stretched, or even reversed? As the 20th century turned into the 21st, science began catching up with myth. What philosophers once dreamed, physicists began to measure. And in their equations, time wasn't a river flowing one way. It was a landscape, a dimension that could, under extreme conditions, loop back upon itself. Einstein was the first to show the door. His theory of relativity revealed that time slows down in strong gravity and speeds up in weaker fields. The faster you move, the slower your clock ticks. Astronauts aboard the International Space Station age fractions of a second less than people on Earth. It's minuscule but measurable, and it proves that time is not fixed, it bends. From there, the possibilities became dizzying. Theoretically, if a spacecraft could travel near the speed of light, its crew might experience only days while years passed on Earth. They wouldn't vanish, they'd leap forward, carried by the curvature of time itself. That's not fiction, that's physics. But what about going backward? That's where things grow stranger. Einstein's equations, extended by later physicists, allow for closed time-like curves, paths through space-time that loop back to the same point in the past. These curves arise near rotating black holes or Kerr singularities, where the spin of mass twists space-time like a whirlpool. In such places, the future and the past could, in theory, touch. One of Einstein's students, Kurt Gödel, even found an exact solution to relativity's equations, describing a rotating universe where time travel would be possible simply by moving in a circle. His discovery disturbed Einstein so deeply that he quietly distanced himself from it, perhaps realizing what it implied. The laws of the cosmos themselves do not forbid time travel. In the decades that followed, theoretical physics became a battleground between possibility and paradox. In the 1980s, physicists Kip Thorne and Igor Novikov explored the idea of wormholes, tunnels connecting distant points in spacetime. Thorne proved that if a wormhole's ends moved differently in time, say one traveling at near light speed, stepping through it could allow a traveler to emerge before they entered. Novikov's principle of self-consistency argued that any event created by such travel must be compatible with history, meaning you could visit the past but never change it. You could cause the events that already happened but never erase them. Then came quantum mechanics, the realm where reality itself dissolves into probabilities. In the quantum world, particles can exist in multiple states until observed, suggesting time may also be layered. Not a single line, but countless overlapping possibilities. The many worlds interpretation proposed that every event creates new universes, one where you turned left, another where you turned right. In that light, time travel doesn't rewrite the past, it simply moves you to a different timeline, a different branch of the cosmic tree. This idea eerily echoes John Titor's claims from Part 2. You cannot change your future. You can only change the world line you are on. Was he quoting quantum theory or living it? As technology advanced, science began to test the limits. In 2011, experiments at CERN seemed to show neutrinos traveling faster than light, a potential key to time reversal, though the results were later corrected. Still, in laboratories around the world, researchers now manipulate particles that behave as though they move backward in time. Quantum entanglement, for instance, links two particles so completely that changing one instantly affects the other, even across vast distances. Some physicists describe this as information traveling outside time. If communication can transcend time, what about consciousness? Dr. Roger Penrose and Stuart Hameroff proposed that the brain's microtubules might operate on quantum principles, meaning thought itself could interact with time at the smallest scales. Déjà vu, prophetic dreams, sudden memories of events not yet lived. Could these be glimpses through the thin membrane separating now from then? But physics, for all its elegance, remains bound by reality. Energy is the gatekeeper. To bend space-time enough for a human to travel through, one would need energy equivalent to several suns. It's possible, mathematically, but currently unimaginable to achieve. Some scientists speculate that civilizations far older than ours might have found ways to harness such power, using rotating magnetic fields or exotic negative energy to open controlled wormholes. And yet, haven't we already seen hints of that? The Philadelphia experiment's swirling magnetic vortex, the Montauk Project's rumored time tunnels, Moberly and Jourdain's stillness. Coincidences or early uncontrolled brushes with technology we barely understand? Dr. Ronald Mallett, a physicist at the University of Connecticut, has spent his career designing a time machine based on circulating laser beams. His concept? Twisting space with light itself, creating a continuous loop where information, or perhaps a small object, could travel backward in time. Mallett's model remains theoretical, but his equations align disturbingly well with the patterns described in those classified experiments of the past. Meanwhile, at NASA's EagleWorks laboratory, scientists have explored the concept of an Alcubierre drive, a warp bubble that contracts space ahead of a ship and expands it behind it. It doesn't technically move faster than light, it moves space itself. And within Einstein's framework, a warp bubble could, under certain conditions, fold time along with space. In other words, the same technology that might carry us to the stars could also carry us into yesterday. Still, every advance comes with a warning. Stephen Hawking once proposed the chronology protection conjecture. The universe, he said, forbids time travel on a macroscopic scale because paradoxes would tear reality apart. If time travel were possible, Hawking quipped, we'd already be overrun by tourists from the future. And yet, maybe we are, quietly, invisibly. If time travel exists, it may not be as dramatic as a machine vanishing in a flash of light. It might happen in the silence of subatomic particles or in the subtle drift of probabilities. Perhaps it occurs every moment, at the quantum level, as the universe continually rewrites itself. Every déjà vu, every impossible coincidence, every historical mystery might be evidence of these tiny fractures, the echoes of timelines brushing against one another. Maybe that's why we find ancient maps showing lands that shouldn't exist, or why inventors discover ideas decades before they can be built. Perhaps inspiration itself is a form of time travel, information leaking backward through the lattice of consciousness. The truth may not be that time travel will exist someday. The truth may be that it already does, woven invisibly into the laws of physics, appearing wherever gravity, magnetism, and memory collide. In the end, time travel might not be about machines or portals. It may be about understanding the hidden symmetries of the universe and of ourselves. Because every second that passes, we are all travelers, moving relentlessly through time's vast landscape. The past clings to us, the future pulls us forward, and somewhere between them lies the impossible, a doorway not to another era, but to the realization that time, like reality, may be far stranger than we can ever imagine. And perhaps in some forgotten archive, on some hidden reel of classified film, there is proof, a flicker of light, a ship that vanished, a man who appeared out of nowhere, waiting for the moment when humanity is finally ready to understand that the line between science and the impossible was never a line after all.